Let's do one last problem here. We want to again find a z-score, but this time they tell us our percentage or our probability here is going to be to the right of our value. So I can still draw my curve. Doesn't have to be perfect. And what we're going to draw in is it's going to be somewhere down here because I want all of this area on the right to be 78.5%. Or remember, another way of saying that is as a decimal, it would be 0.785. So remember, I want to find the z value for that, so I need to find the z, which means I'm going to use the inverse norm function on my calculator. The problem is it needs an area to the left. And right now I only have an area to the right. But I can find the area to the left because the area to the right and the area to the left are complements. They need to add up to 1. So if I do 1 minus the 0.785 that I already have, this will be the area to the left. So 1 minus 0.785 gives us 0.215 going to the left. So that's what I would input to my inverse norm, the 0.215, because it's an area to the left. And then I can have my calculator compute that z value using the inverse norm function. So let's go ahead and do that. What we get is a negative 0.79, and again that is a z value that gives an area to the right of 78.5% or 0.785, and the other 21.5% is on the left. Now, just to kind of summarize what we've done so far. In 6.1, what we did is we took z's and converted them into areas or probabilities using the normal CDF. And then, also in 6.1, we took our areas and probabilities and turned them back into z-values using the inverse norm. That's what we did in 6.1. Then in 6.2, we said, okay, what if we don't have a z-value? What if we've got a regular data value? So let's call that x. We still use a normal CDF to find the area or probability. We just had to give it 2 extra pieces, the mean and the standard deviation. And we're still going to be able to work in reverse. Take our area and probability and convert it back into a regular number. This won't be a z-value, it'll be a regular data value. And we'll still use the inverse norm. But just like the normal CDF, we had to give it some extra information. We'll have to give the inverse norm some extra information. We'll have to give it the same extra information. We'll give it the mean and the standard deviation in that order. So again, how do you get the inverse norm function on your calculator? Remember, it's still that second Navarre's and distribution key. It's right below the normal CDF. It's option 3. And just like before, we're going to, into our inverse norm function, always plug in first an area to the left. Except for normally we've stopped there when we were looking for a z-value. Because we're not going to be looking for a z-value anymore, we're going to have to give it more information, just like the normal CDF. We'll have to give it a mean first, our mu, and then we'll have to give it our standard deviation, which is our sigma, last. And then we'll close it off. Notice the extra information we're giving it, the mean and the standard deviation, is the exact same extra information we had to give the normal CDF in the exact same order. So that's what we're going to look at next, is using the inverse norm when we already have an area or a probability to turn it back into a regular value.